In this video, I'm going to show you how to find the average value of a function. Now, you already know how to find the arithmetic average. That is where you add up all the data and divide by the number of data points. So that could be written as y average is equal to y1 plus y2, and so on until you get to the last number, yn, and then we divide by n, which is how many numbers there are. Now, what happens when we have a function which is continuous and we want to divide it up into infinite number of subintervals? Well, let's say that we have this function, and let me draw something that looks like this. And this is A, and this is B. So first, what we're going to do is we're going to divide the interval A to B into n subintervals. Okay, so this is our function. And we're going to divide it up into lots and lots of little pieces from A to B. Okay. Next, we're going to say that delta x will equal to B minus A divided by n. So that's going to be the width of each of these subintervals. So from here, we know that then n is equal to b minus a divided by delta x. So calculating the average, we can say that we have f of x1, which is the first y value, plus f of x2, the second y value, and so on until we get to the last y value, f of x sub n. We divide by how many points there are. Okay, but now we know that n is equal to b minus a divided by delta x. So we're going to substitute that in. And then when we divide, we get delta x divided by b minus a times f of x1 plus f of x2 plus ... and so on, all the way to f of x sub n. All right, so this is the same as writing this as 1 over b minus a, and the sum, I'm going to use the sigma notation, of all of these y values, so f of x sub I, and then I'm going to take the delta x and multiply that too, and have that written at the end. So as you can see, this sigma notation, the sum, gives us a nice little formula here using the integral. So we can say that if f is continuous on a to b, then the average value of f on the interval a to b is defined to be f of average equals 1 over b minus a, and then we have the integral from a to b of f of x dx. So to understand this geometrically, the average would be, I'm going to mark this down, so let's say it was approximately right here. So this distance here would be the f average. This means that if I add up all the y values underneath this graph between the x-axis and the graph, the average y value would be approximately right over here. Well, at least in this graph. So let's take a look at an example. So find the average value of f of x equal to 4 minus x squared on the interval from 0 to 3. So using the formula, we have that the average is equal to 1 divided by, so b minus a, so this would be 3 minus 0, and the integral is from 0 to 3, and our function is 4 minus x squared, and then dx. So we have 1/3, and then we're going to find the integral. This would be 4x minus x cubed divided by 3, and we're going to evaluate from 0 to 3. So we have 1/3, and then 12 minus 27 divided by 3. So that's going to be 9. So 12 minus 9 is 3. And then 1/3 of 3 is equal to 1. So that means that with this parabola, this upside down parabola, from 0 to 3, the average y value would be 1. To understand this, let's draw a graph. So we have the parabola, which has a vertex at 4, and it points down. Okay, so what we have is these y values here and here. And so the average would occur at y equals 1, which is here. So this little, well, not little, but this number here, this y value here would be our average. So the next question I'm going to ask you is, now knowing that the average is 1, at what x value does this average value occur? So what we can do is we're going to take the 1, plug it into f of x, and then find our x value. So we have x squared equals 3, so x equals plus or minus root 3. However, we're going to reject the negative root 3 because we only want the value to be between 0 and 3. So we're going to reject x equals negative root 3 because it does not, or it is not in the interval 0 to 3. So therefore, x is only root 3. The second thing I want to show you is the mean value theorem for integrals. So sometimes we want to know the specific value between a and b of a function, which will produce the same average value of the function. So let me draw a graph to show you what I mean. So let's say we have y equals f of x, which is this graph here. And this point here is a, and this point is b. So what we have is there is an area underneath this graph. Which we can calculate. All right, so there is some point C from A to B such that the height f of C will form a rectangle with the base from B to A that will have the same area as this area underneath the graph. Now I'm going to arbitrarily draw it on this picture, but let's say that area or that point was right here. So let's say that this is value C. Okay, and we'll call this f of C, such that the area in this rectangle is the same area underneath this blue curve. Okay. So maybe I should identify what that same area is. So that is the area under the graph of f of x. And this is called the mean value theorem. And this is for integrals. So if f is continuous on a to b, then there is at least one number c in a to b such that the integral from a to b of f of x dx, so that's the area under the curve, is equal to f of c, which is the height of the rectangle, multiplied by b minus a, which is the width of the rectangle. So let's take a look at one example. So find the mean value of f of x equal to x squared minus 1 on the interval from 0 to 3. So using this formula from above, what we have is the integral from 0 to 3 of x squared minus 1 dx is equal to f of c times 3 minus 0. So integrating on the left, we get x cubed over 3 minus x. Integrating that from 0 to 3. F of c means that we're going to take the c value and plug it into x squared minus 1. So we have c squared minus 1 all times 3. So on the left, we get 27 over 3 minus 3 equals to 3c squared minus 3. And so we have 9 minus 3 equals 3c squared minus 3. 9 minus 3 is 6. Move the 3 over, we get 9. So now we have c squared, divide both sides by 3, and we get c squared equals 3. So c equals plus or minus root 3. Now, it's just a coincidence that it's root 3 again compared to the last example, just because of the function that I've chosen. Okay, so again, we only want to look at the interval from 0 to 3. So therefore, we're going to reject c equal to negative root 3 because it is not in the interval 0 to 3. So therefore, c is only equal to the positive root 3. Let's take a look to see what this looks like graphically. So I'm going to draw a parabola here. So the x squared minus 1. So it starts with a vertex of negative 1. And it's going to go 1, 2, 3, 4, 5, 6, 7, 8, up to 9, which is 8 actually. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to go 3 because it's from 0 to 3. So I want to know what's happening over there. So just graphing this very quickly, I get a parabola that looks something like this. And the area underneath this parabola would be this part here, which I'm going to shade in green. So the mean value theorem for integrals states that this area that I'm shading in green is the same as having x value or a c value of root 3. So that's approximately 1.732. So that's about here. So that would be the same as the area in this rectangle that I'm going to color in black. Now I know that this y value because if I plug in the root 3 into f of x here, I can see that this will be 3 minus 1, which is 2. So the y value is going to be 2. Now I didn't ask you for the y value, so it's sufficient just to say that c is equal to root 3.